Imagine stepping out of time machine and finding yourself standing on Earth nearly 300 million years ago. There are no cities, no roads, no airplanes, no humans. There is not even a familiar world map. Instead, an enormous supercontinent stretches across the planet, surrounded by a seemingly endless ocean. The air feels different. The climate is changing. Strange creatures move through forests that look nothing like the forests we know today. And somewhere in this ancient world, predators with enormous jaws are hunting their next meal. This was the Permian Period, one of the most fascinating and terrifying chapters in the history of our planet. It was a world of giant insects, sailback predators, primitive reptiles, strange mammal-like animals, massive forests, volcanic landscapes, and eventually one of the greatest catastrophes Earth has ever experienced. So what would it actually be like to walk across Earth during the Permian? What creatures would you encounter? And how did this seemingly thriving world eventually become the stage for the most devastating mass extinction in Earth's history? Let's travel nearly 300 million years into the past and find out. Welcome back to Future and Facts Hub. Today we're going deeper into Earth's ancient past. Long before humans appeared, and even before dinosaurs became the dominant animals on land. Our journey begins around 299 million years ago, near the beginning of the Permian Period. At this time, Earth's continents were moving toward one another, and had eventually formed a gigantic supercontinent known as Pangaea. Imagine taking almost all the major land masses we recognize today, and pushing them together into one enormous continent. That was Pangaea. Surrounding it was Panthalassa, a massive global ocean covering much of the planet. If you could look down at Earth from space, the planet would be almost unrecognizable. But the Permian world wasn't simply a giant prehistoric jungle. Its climate was constantly changing. The period began as Earth was emerging from a major ice age. Large areas of the southern continents had been covered by enormous ice sheets, and temperatures in many regions were much cooler than they would become later. But as the Permian progressed, the climate began shifting dramatically. The planet gradually became warmer and, in many places, much drier. And this changing environment would become one of the greatest forces driving evolution. The forests of the earlier Carboniferous world were already beginning to disappear. Giant swamp ecosystems that had covered huge areas were shrinking as conditions became less wet. But life is remarkably adaptable. Plants that reproduced using spores were increasingly joined by plants capable of producing seeds. These seed-producing plants had a major advantage, because their seeds could survive dry conditions much better than delicate spores. Conifer-like plants and other gymnosperms began spreading across the increasingly dry landscapes of Pangaea. The world was changing, and life was changing with it. And then there were the insects. If you think modern insects can be disturbing, imagine encountering some of their ancient relatives. The atmosphere and ecosystems of the distant past allowed some arthropods to reach impressive sizes compared with many species today. Ancient forests were filled with insects crawling beneath leaves, flying between plants, and feeding on vegetation. Beetle-like insects, cockroach relatives, and other arthropods were already part of Earth's ecosystems. You wouldn't be walking through a quiet forest. Every step could disturb something hiding beneath the vegetation. But insects weren't the creatures you needed to fear most. Something much larger was moving through the forests. One of the most famous animals of the early Permian was Dimetrodon. Despite its appearance, Dimetrodon was not actually a dinosaur. In fact, it wasn't even a true lizard. It belonged to a group called synapsids, an evolutionary lineage that would eventually give rise to mammals. That means this strange sailback predator was part of a branch of life that was far closer to our own evolutionary history than the dinosaurs were. Dimetrodon could reach several meters in length and carried a spectacular sail along its back. Imagine seeing one in the distance. Its body would move low to the ground, its powerful jaws opening and closing as it searched for prey, while a giant sail rose above its spine. The sail may have played a role in regulating body temperature, although scientists continue to investigate exactly how it functioned. Whatever its purpose, it made Dimetrodon one of the most recognizable animals of the Permian. And those jaws were not designed for eating plants. Dimetrodon was a predator. Its teeth were specialized, and some species possessed large, canine-like teeth capable of delivering a devastating bite. If you were somehow standing in the middle of a Permian forest and saw one approaching, there would be no friendly encounter. You would be looking at one of the top predators of its ecosystem. But Dimetrodon wasn't the only predator experimenting with new body designs. As millions of years passed, synapsids continued evolving. The Permian became a massive evolutionary laboratory. Different animals developed stronger jaws, more efficient bodies, and increasingly upright limbs. Some were predators. Others were herbivores. Some probably ate a mixture of foods. And many of these creatures looked strange by modern standards. Among them were therapsids. Therapsids represented an important stage in the evolutionary history leading toward mammals. Their bodies were generally more advanced than those of many earlier synapsids. Their legs became positioned more beneath their bodies, giving them a more efficient walking posture. Their skulls and jaws were also changing. Some species were heavily built plant eaters, while others became powerful hunters. One group, the Gorgonopsians, would later become some of the most frightening predators of the late Permian. These animals possessed long, canine teeth and powerful skulls. They weren't dinosaurs. They weren't mammals. They were something in between, representing a completely different chapter in the story of evolution. And while strange creatures were taking over the land, the oceans were evolving too. Imagine diving beneath the surface of Panthalassa. The underwater world would be almost as alien as the land. Ancient sharks moved through the water. Primitive bony fish swam between reefs and rocky environments. Marine predators hunted smaller animals, while countless invertebrates occupied the seafloor. But the oceans were not stable. As the climate changed, sea levels rose and fell. Ocean temperatures shifted. Atmospheric chemistry changed. Ecosystems expanded in some regions and collapsed in others. Life survived by adapting again and again. This is one of the most important things to understand about the Permian. It wasn't one single environment. It lasted for roughly 47 million years, which is an unimaginably long period of time. During those millions of years, Earth's climate, geography, oceans, and ecosystems changed dramatically. To put that into perspective, modern human civilization has existed for only a tiny fraction of that time. The Permian was long enough for entire ecosystems to appear, transform, and disappear. And eventually, the planet became much hotter. As Pangaea grew larger and more continental in character, enormous interior regions became increasingly dry. Coastal areas could still support life, but deep inside the supercontinent, conditions could become harsh. Seasonal extremes became stronger. Some places were covered by forests, while others resembled enormous deserts. And then came the late Permian. This was when some of the most bizarre creatures in Earth's history appeared. One of them was Dinosaurs, a stocky herbivorous synapsid with a short body and powerful limbs. It looked somewhat like a strange combination of a pig and a reptile. Dinosaurs wasn't a giant monster. It was relatively small compared with some of the predators of its time, but its evolutionary story would become incredibly important. Another important group was the cynodots. These animals were more mammal-like than earlier synapsids and possessed features that pointed toward the future evolution of mammals. Some had specialized teeth, more advanced jaws, and body structures that made them increasingly different from their distant ancestors. Earth was slowly building the evolutionary foundations that would eventually produce mammals. But while life was evolving, something much bigger was happening to the planet itself. Volcanic activity was increasing, and this is where the story takes a dark turn. Deep beneath the surface of what is now Siberia, enormous volcanic eruptions eventually began releasing tremendous amounts of lava and volcanic gases. These eruptions were not like a single volcano suddenly exploding and disappearing. They occurred across an enormous region and continued over a very long period of geological time. The result was catastrophic. Huge quantities of carbon dioxide and other gases entered the atmosphere. As greenhouse gases accumulated, global temperatures increased dramatically. The climate became increasingly unstable. Ocean chemistry changed. Oxygen levels in many marine environments declined. The planet was entering a dangerous feedback loop. Warmer oceans hold less oxygen. As ocean circulation changes, oxygen can become even harder to distribute. Marine organisms begin struggling. Some ecosystems collapse. As ecosystems collapse, the food web begins breaking apart. And then things became even worse. Volcanic gases didn't only affect temperature. They also contributed to chemical changes in the atmosphere and oceans. Acidification and toxic conditions could develop in marine environments. Some areas of the ocean may have become almost completely depleted of oxygen. Imagine being a fish living in an ocean where the water around you is slowly becoming impossible to breathe. There is nowhere to run. And on land, animals were facing their own crisis. Temperatures were rising. Vegetation was changing. Water was becoming harder to find in many regions. Food webs were becoming unstable. The Permian world, that had taken tens of millions of years to develop, was beginning to collapse. Then came the event scientists call the Great Dying. Around 252 million years ago, Earth experienced the most severe mass extinction known in the fossil record. The Permian ended, and an enormous portion of life disappeared. The numbers are almost impossible to comprehend. The vast majority of marine species were lost. A huge proportion of land vertebrates disappeared. Entire groups that had survived for millions of years were wiped from the planet. This wasn't just the disappearance of a few famous animals. It was an ecological collapse on a planetary scale. Imagine walking through a forest before the extinction. You would hear insects. You would see plants everywhere. You might hear animals moving through the vegetation. Predators would be searching for prey. Rivers and wetlands would support countless organisms. Then imagine that world slowly becoming silent. Plants die. Herbivores disappear. Predators lose their food. Water becomes increasingly hostile. Oceans lose oxygen. Entire ecosystems collapse. The Great Dying wasn't a single moment when every creature suddenly dropped dead. It was a prolonged environmental disaster that unfolded through a combination of factors. Volcanism appears to have played a major role, but scientists continue studying exactly how the different processes interacted. And the most terrifying part is that the planet survived. Earth didn't die. Life didn't disappear completely. Instead, the survivors entered a radically different world. Some small animals endured. Certain plants survived. A handful of marine groups made it through. And among the survivors were ancestors of creatures that would eventually dominate the next chapter of Earth's history. The extinction opened ecological space, and evolution rushed into it. Only a few million years later, the Triassic period began. The dinosaurs were still waiting in the future, but their rise would not have been possible without the catastrophic extinction that transformed the planet. That's what makes the Permian so fascinating. It wasn't simply a time when giant prehistoric creatures walked across Pangaea. It was a period of enormous evolutionary experimentation. Animals were developing new body plans. Plants were adapting to increasingly dry environments. Continents were changing. Oceans were transforming. Climate was shifting. And then the entire system nearly collapsed. When we imagine prehistoric Earth, we often think of dinosaurs first. But dinosaurs appeared after the Permian. Before them came a world ruled by synapsids, reptiles, amphibians, insects, sharks, and countless organisms that have no living equivalent today. The Permian reminds us that Earth's history is not a straight line. It is a story of survival. Species appear. Species disappear. Climate changes. Continents move. Oceans rise and fall, and life keeps adapting. If you could somehow stand on Pangaea 270 million years ago, you wouldn't recognize the planet beneath your feet. The sky would look different. The landscapes would be different. The animals would be different. Even the sounds of nature would be completely unfamiliar. You might see a Dimetrodon moving through the vegetation. You might watch strange synapsids competing for territory. You might see insects crawling through ancient forests. And far away, enormous volcanic forces could already be preparing the planet for one of the darkest events in its history. That's the terrifying beauty of deep time. Earth can look completely stable for millions of years, while beneath the surface, forces are constantly reshaping the future. The Permian lasted for tens of millions of years, but eventually it became the doorway to a new world. A world where the survivors would evolve in unexpected ways. A world that would eventually produce dinosaurs, then mammals, then primates, and hundreds of millions of years later, us. So the next time you look at a map of Earth, remember that the continents beneath your feet are only temporary pieces of a much larger story. The planet has already assembled and broken apart supercontinents. It has frozen. It has burned. It has experienced extreme climate changes. It has lost most of its species. And somehow life kept going. The Permian was one of Earth's greatest tests. And life survived. If you enjoyed this journey into the ancient world, make sure you stay with Future and Facts Hub, because there are still countless chapters of Earth's history waiting to be explored. From the first terrifying predators to the rise of the dinosaurs and the creatures that eventually led to humanity. Our planet's past is stranger than almost any science fiction story.